Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Here we have been provided with orthographic front view, top view and the right hand side view projections corresponding to this engineering object, and we are required to obtain the 3D isometric projections corresponding to this engineering object over here. So in order to obtain the isometric projections corresponding to this engineering object, so we have to convert the true length dimensions which are available with us into the isometric projections over here. So all the true length dimensions, they will be marked alongside this true length scale, and the corresponding isometric distances we are going to obtain, and these isometric distances we have to plot onto the 3D isometric projection construction which we are going to obtain over here. So in order to obtain the 3D isometric projection construction corresponding to this engineering object, we need to evaluate the front view face, the right hand side view face and the top view face corresponding to this engineering construction into a 3D isometric projection over here. So we need to find out the dimensions of the front face of the solid, the dimensions of top face of the solid and the dimensions of the side face of the solid. So while we observe the orthographic projections corresponding to this engineering object, so we observe that the length of the solid happens to be 60 millimeter, while the height of the solid happens to be 50 millimeter. So the front view face, it will be located into this orientation such that the length dimension will be plotted alongside the isometric x-axis and the height dimension will be plotted alongside this isometric y-axis over here. So into this face, which is going to measure 60 millimeter length and 50 millimeter height, the components of the front face of the solid, they will be obtained over here. Similarly, corresponding to the top face, we can observe the length happens to be 60 millimeter while the width of the solid happens to be 50 millimeter. So the top face of this solid will be obtained alongside the isometric x-axis and the isometric z-axis over here. So alongside this xz plane, which is going to measure 60 millimeter length and 50 millimeter width, we are going to obtain the detailing regarding the top face elements corresponding to this engineering object over here. And finally, corresponding to the side face, we have observed the dimensions will be 50 millimeter by 50 millimeter. So we can check this dimension of the width happens to be 50 millimeter, which we have obtained from the top view projection, and the height of the solid happens to be 50 millimeter. So this height has been marked into the front view projections over here. Now the right hand side view projections will be obtained alongside this YZ plane over here. So alongside y-axis, the height of the solid will be evaluated, and alongside z-axis, the width of the solid will be evaluated. So alongside this YZ plane, the elements corresponding to the right hand side view, they will be obtained into the isometric projections over here. So now let us proceed with the evaluation of isometric projections corresponding to this engineering object over here. So to begin with, as we have discussed, all the true length dimensions available in the orthographic projections, they need to be converted into the isometric length projections over here. Now we can proceed with the evaluation of the isometric projections corresponding to the solid, in which all the three faces, that is front face, top face and the right hand side view face, they will be available into a single 3D geometric construction over here. So now this is x-axis alongside which the length of the solid will be depicted. this is isometric y-axis, alongside which we are going to depict the height of the solid over here. And this is the z-axis, alongside which we are going to obtain the width dimensions of this particular solid. So we know that the length of the solid happens to be 60 millimeter. So into the front view projections, we have obtained the length is equal to 60 millimeter. And into the front view projections, we will also observe that the height of the solid happens to be 50 millimeter. And the width of the solid, we have also obtained that this is equal to 50 millimeter. This is the width of the solid. So the three dimensions, length, height, and the width of the solid we have obtained. Now, once we draw this isometric projection line, which will be parallel to the z-axis and it measures 50 millimeter, now we are going to obtain another isometric line originating from this point of the base, measuring 60 millimeter and parallel to the x-axis over here. So the projections corresponding to the base of this engineering object, they have been obtained alongside xz plane over here. This is x-axis, this is z-axis. So alongside xz plane, the base dimension they have been obtained over here. Similarly, once we draw isometric projection line originating from this point, measuring 50 millimeter height parallel to the y-axis, and another isometric projection line measuring 60 millimeter parallel to the x-axis over here. So now this front view face corresponding to this engineering solid, it has been obtained over here. Similarly, in order to obtain the right hand side view face over here, now we will see that we need to draw two isometric projection lines over here. One isometric projection line like this, measuring 50 millimeter parallel to the z-axis, and another isometric projection line which is going to be parallel to the y-axis and it should be measuring 50 millimeter. So once we obtain these two isometric projection lines, now the right hand side view face construction corresponding to this solid, it has been obtained over here. Now in order to obtain the top face of the solid, so two more isometric projection lines we need to obtain over here. So this isometric projection line will be measuring 50 millimeter. It will be parallel to this isometric projection line and it will be parallel to the z-axis. And this isometric projection line will be measuring 60 millimeter. It will be parallel to this edge and this edge, and this will be parallel to x-axis over here. So in order to obtain the rear side face, this vertical isometric projection line now we need to obtain, so that this is the rear right hand side view face. This is the rear side of the front view face which we have been able to obtain over here. So this way an isometric cuboid projections we have been able to obtain corresponding to the length of the solid is equal to 60 millimeter, width of the solid it is equal to 50 millimeter, and height of the solid it is equal to 50 millimeter. So this way the basic framework construction corresponding to this engineering solid has been obtained over here. So let us now evaluate the basic construction of this engineering object and obtain the 3D isometric projections corresponding to this engineering object whose orthographic projections they have been provided to us. So now we can check over here into this solid as we observe the front view, the right hand side view, and the top view projections over here. Three things we can observe over here. From the top view we can check there is a vertical web which is going to lie towards the rear side of the solid over here, which is going to have a thickness of 15 millimeter. And another thing we can check it out over here, that this rear web, it is going to move down by a distance of or by a height of 15 millimeter as it is shown over here. So once we move down by 15 millimeter, now we have encountered this inclined surface of the solid which is going to start from a point 15 millimeter away from the rear end, 15 millimeter below the top surface of the solid, and this inclined surface, it is going to move towards the front side of the solid, and it will be extended up to this portion of the solid over here. So this is the second thing we have observed through this orthographic projection, that there is a sloping portion which is available with us as it is visible to us from the right hand side view, and up to what particular length this sloping portion will continue. So this information will be available with us from the front view projections over here, that this inclined portion, it will be available with us up to a length of 36 millimeter from the right hand side face of the solid. So from this corner we are going to have up to a distance of 36 millimeter. There will be a sloping cross section of the solid which is going to move till the point which will be at a distance of 15 millimeter from the rear surface and 15 millimeter from the top surface of the solid, so that we should be able to obtain this distance should be 15 and this distance should also be 15. And now we can see there is a vertical web over here towards the left side of the solid, as we observe from the top view construction over here. So this vertical web, it is going to have a top inclined surface over here. Again we can check over here, this vertical web which is going to have a thickness of 24 millimeter from the left hand side face of the solid. So we can check, this is the left hand side face of the solid. So from the left hand side face of the solid, there will be a vertical web which is going to extend from the front side, and the thickness of this web will be equal to 24 millimeter, and this web happens to be vertical up to a distance of 35 millimeter from the base, and then this will become inclined towards the top surface of this particular solid over here. So another inclination we are going to observe towards this particular portion of the web over here. So that is where we can check, this portion will be vertical over here, 24 millimeter by 35 millimeter. So 24 millimeter by 35 millimeter will have a vertical web, and this top portion of the web will be inclined in such a way that the width of this web will be 24 millimeter, and this inclined portion, it is going to start from the front of the solid till the point 15 millimeter from the rear surface of the solid over here. So this way we have discussed using the information available with us from the front view, right hand side view and the top view orthographic projections over here, how we will be able to obtain the isometric projections by dividing this object into multiple elements over here. So we can see, as we have discussed, we have observed that from the top surface we are going to have a web which is going to have thickness of 15 millimeter over here, and this web will be located towards the rear face of this particular solid over here. So from the rear face of the solid we have marked the thickness of the web, it is equal to 15 millimeter over here. So this information from the top view projections we have used over here. Now another information we have, that this web, it is going to continue straight because this portion of the web happens to be straight. So this portion will be the straight vertical web over here. So corresponding to a distance of 15 millimeter from the rear face. Now we have drawn a vertical projector isometric line over here in such a way that this height of 15 millimeter we are going to measure, so that there will be a flat surface over here which is going to measure 15 millimeter as the height, 36 millimeter as the width over here. So up to this distance we are going to obtain the flat surface of the web over here. And now we can check, this distance happens to be 36 millimeter. Where from we have obtained this distance of 36 millimeter? It is this distance over here. So corresponding to this distance or the length of 36 millimeter, from the right hand side face of the solid. So from the right hand side face of the solid, so 36 millimeter towards the left hand side as we move. So at a distance of 15 millimeter, now we can see at a distance of 15 millimeter, now we are going to obtain a sloping portion, and this sloping portion will start from these 2 points over here and 2 points over here. So we can check 15 millimeter height we have marked over here from a point 36 millimeter from the right hand side face of the solid. This is right hand side face of the solid. So 36 millimeter as we move towards the left side. This will be a flat vertical web which is going to measure dimensions 15 millimeter height. 36 millimeter is the length of this particular web. Now these are two base points. Now we can check from the side view. So this web is going to continue like this, and now there is a sloping portion over here. So this sloping portion is going to continue up to this distance over here. So this distance happens to be 36 millimeter length. So from this point we join this point, from this point we join this point, so that this sloping cross section we are able to observe over here. So now we have been able to justify two things. We can check this is the inclined portion of the web and the vertical portion of the web, which has been clubbed into the side view projection over here. Corresponding to this inclined surface, the apparent shape we have obtained into the front view projection. Corresponding to this vertical web, the true shape has been obtained into the front view projections over here. So this way, so this inclined web and a vertical web we have been able to obtain over here. Now we can check, this was the vertical web which was available with us into the top view projection. So this vertical web also we have obtained into the top view projections over here. But corresponding to this portion of the vertical web which is available with us onto the left hand side face of the solid. So one more thing is available with us, that this vertical web, it has again got two segments over here. We can check this vertical web, it has got two segments. How do we identify it has got two segments? Because there is a solid or the object line which is going to divide this portion of the vertical web which is going to lie onto the left hand side of the solid. So now we can check at a depth of 15 millimeter from the top face, we have obtained an inclined surface over here. So this inclined surface of this vertical web, it will be extending from this top portion. So this top portion is 15 millimeter from the rear face of the solid. It means from this point and from this point. So again there is a vertical inclined web over here which is going to extend up to a distance of 15 millimeter from the top face into the front face of this particular solid, because this projection line, it is going to convey to us that this vertical web inclination, it starts from this point and this point, whereas this location over here, it is 15 millimeter from the top surface over here. So now if we join these two inclined lines over here, now we will see corresponding to this inclined web which is available with us towards the left hand side surface of the solid over here. So corresponding to this inclined surface, the side view will be projected as an inclined surface over here, and into the front view we are able to obtain the apparent shape of this inclined surface over here. And then we can check the lower portion of this web happens to be vertical into the side view projections over here. So now we can have this rectangular surface which is going to measure 24 millimeter length and 35 millimeter, it is the height of this rectangular cross section over here. So this rectangular cross section true shape is available with us into the front view projections over here, and this vertical edge means that there is no change in cross section at the front face over here. So this way we are able to obtain the apparent shape projections corresponding to this inclined web into the front view projections, the apparent shape projections corresponding to this inclined web into the top view projections over here. So this projection will be apparent shape. Similarly, corresponding to this inclined portion of this web, so the top view projections, they will also be the apparent shape projections over here. So whereas in the top view, this surface happens to be parallel to the horizontal plane, so corresponding to this rectangular web, which is going to measure 15 millimeter by 60 millimeter, we are going to obtain true shape projections corresponding to this vertical web, which happens to lie on the rear side of the solid. So this way we have been able to convert the information which was provided to us through the front view, top view and the right hand side view orthographic projections into the 3D isometric projection view over here. So let us join various edges over here. So this is the rectangular surface which we have discussed, which will be available onto the front side. Again we can check from the right hand side. So this is the portion which we have obtained over here, the vertical portion, and this is the inclined portion. So this is vertical portion of the rear side web, and this is the inclined portion which is corresponding to this web over here from the right hand side projection. Again, this is the true shape which we had obtained into the top view projections over here. So this surface is also true shape. This surface is obtained as true shape into the right hand side view projections over here. Similarly, corresponding to this inclined web at the top, so we have been able to obtain the isometric projections, and now this is the vertical portion of this web over here. This is the vertical portion of this web over here which we have obtained. And again we can check this portion of the vertical web. It happens to be parallel to the profile plane. So into the profile plane or the side view projections, so this is also true shape of the inclined vertical web which is located onto the left hand side face of the solid over here. And this portion is also true shape into the elevation projection view because it corresponds to this surface which happens to be parallel to the vertical plane over here. So this way, with the information available through these orthographic views, we have been able to obtain a three-dimensional isometric projection into which the front face, the right hand side view face and the top view face information related to the solid has been projected into a single 3D isometric projection construction over here. So this is all for today. So we will be continuing with further discussion regarding few more illustrative cases of isometric projections of the solids in the coming lectures. So thank you very much. Thanks a lot.